Hi, in this video we will talk about rationalizing the denominator. What that means is we're going to try to talk some sense into the denominator. Ah, ha, ha, ha. Just kidding. What it means is we're going to get rid of the radical in the denominator. So before we talk about my examples here on the left, let's talk about a couple of rules. When we multiply a radical by itself, so here I have the square root of 3 times the square root of 3, the radical just disappears and I'm just left with 3. So we're going to use that to rationalize the denominators in order to remove the radical from the denominator. So let's look at our first example. In order to get rid of the square root of 4, what can I multiply to get rid of that? Well, I can multiply by the square root of 4. Now whatever I multiply the denominator by, I have to also multiply the numerator by, otherwise I change the problem. Notice I'm multiplying by square root 4 over square root 4. Anytime I have something over itself, it's just 1. So I'm multiplying this basically by 1. Alright, so I'm going to multiply the numerator by square root 4. I get 7. And then if I have two square roots, which I do, I can then do the operation under the radical, 3 times 4. So in the numerator, I end up with 7 square root 12. And now in the denominator, by design, I have the square root of 4 times square root of 4. My radical is going to disappear, and I'm just going to be left with 4. So congratulations, you've talked some sense into the denominator. Ah, ha, ha, just kidding. We've gotten rid of our radical in the denominator, and that's what it means to rationalize. When we have more than one term, such as in the second example, we need to impose a different rule. Recall that if I multiply something and only change it by itself, but I've changed the sign in the middle, my two middle terms disappear and I can get rid of my radicals. In other words, let's FOIL this out. 2 times 2 is 4. 2 times square root of 3, yes, this is a 3, will give me 2 times the minus the square root of 3 gives me minus 2 square root 3, and square root 3 times positive 2 gives me a positive 2 square root 3. And then last, if I do square root 3 times a minus square root 3, I'm going to get a negative, but now I have square root 3 times square root 3. My square root's going to go away and I'm left with 3. And now notice my middle terms cancel out, okay, because a minus 2 square root 3 plus 2 square root 3 gives me 0. And I'm just left with 4 minus 3, or 1. So the way I can eliminate my radical is by multiplying by what we call the conjugate. And the conjugate is just the same thing, change the sign in the middle. So we're going to multiply this by 2 minus the square root of 3. Okay. And I'm going to multiply my numerator by 2 minus the square root of 3. Because whatever I do in the denominator, I have to do in the numerator, so I don't change the problem. Alright, we've already done this out. 2 square root 3 times 2 minus the square root of 3. That's just going to give me a 1. Alright, we did it up here. And now in my numerator, I get 2 square root 3 times 2. I've got to distribute this out. That's going to be 4 square root 3. And then I get 2 square root 3 times a minus square root 3 is going to be minus 2, because 2 times negative 1 is negative 2. And then square root 3 times square root 3 is going to give me a 3. Well, whenever I have a 1 in the denominator, I don't have to write it. So I can simplify this answer to 4 square root 3 minus 6. I can't combine those two terms because my minus 6 does not have a square root 3. So this is my final answer. But notice, by multiplying by the conjugate, or in other words, the same thing I have on the bottom, just change the sign in the middle, I was able to eliminate my radical. Let's do one final example. Here I have 2 square root 3 minus 2, so I'm going to multiply by 2 square root 3. And now because I have a minus over here, I'm going to change that to a plus. 2. Okay, and now whatever I multiply in the denominator, I have to multiply in the numerator. Okay, alright, and now I can just distribute this. I got 7 square root 2 times 2 square root 3. 7 times 2 is 14. The square root of 2 times square root of 3 gives me the square root of 6. Next, I'm going to do my next term. 7 times 2 is 14, and then I have a square root 2. So that's what my numerator simplifies into. My denominator would simplify into 2 square root 3 times 2 square root 3 is going to be 4 times 3. 2 times 2 is 4, and then when I multiply my square root 3 times square root 3, my square root goes away and I'm just left with 3. I get 2 square root 3 plus 2 square root 3 times 2 square root times 2, sorry, that's going to be 4 square root 3. My next term is the inners. Minus 2 times 2 square root 3 is going to be minus 4 square root 3. And that's a good thing, because by design I want these to cancel, and sure enough they do. 4 square root 3 minus 4 square root 3 is going to give me 0. And then my last term is just a minus 2 and a positive 2, so that's going to be a negative 4. So in my denominator I'm going to be left with 4 times 3, which is 12, then minus my 4, which is 8. So my denominator just becomes the number 8. Alright. And my numerator, I could pull out a 14 and write this in a different way. Square root 6 plus square root 2. Square root 6 plus square root 2. But you could also just leave it the way you had it. Alright. The square root of 14 square root of 6 plus 14 square root of 2. Alright, I hope this helps you talk some sense into your denominators. Ah ha ha ha, just kidding. I hope you realize now how to rationalize. If it's just one radical, multiply by that radical. If you have two terms, then multiply by the conjugate. Conjugate means you're multiplying by the same thing, just changing the sign. Here I had a positive, so I multiplied by a negative. Here I had a negative multiplied by the positive, so just change the sign in the middle of your terms.